Hi everyone, this is your struggling CS student, and today let's solve another LeetCode problem of the day. Let's take a look at today's problem. 1578. Minimum time to make rope colorful. Okay, it's a 15 to 1600 rated question, medium, so hopefully not too bad. Alice has n balloons arranged on a rope. Okay, you are given a zero index string colors where colors of I is the color of the ith balloon. She wants the rope to be colorful. She does not want two consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a zero index integer array of needed time, where needed time of I is the time in seconds that Bob needs to remove the ith balloon from the rope. Return the minimum time Bob needs to make the rope colorful. Okay, let's see the constraints first. N is 10 to the power 5. Okay, so we need to be relatively fast. And for the rope to be colorful, two consecutive balloons cannot be of the same color, so you have to remove that. So let's see. Okay, okay. I guess we can just group the colors, group the balloons by their colors in sequence. So, for example, like you see here in the first example, you have this sequence of two balloons, right? Then what you can do is for a particular sequence, right, um, you have to remove all of the balloons except for one balloon, right? That's because the balloons are arranged on a rope and there can't be any two consecutive balloons that are the same color. So if let's say here there are like 3 or 4 blue balloons, then actually you have to remove n minus one of them, right? You can only keep one of them so that the consecutive balloons are different colors. So in that case, uh, you will want to keep the balloon that takes the longest to remove. You want to keep the balloon that is the longest to remove. Yep. So let's see the example here. So A, B, A, C, right? So we see these two A here, which corresponds to these four. We actually want to keep the balloon that takes the longest to remove. So we remove the balloon that we can remove the fastest. So that's the strategy. It's kind of like a greedy strategy. So it depends on how you want to build the sequence. And from there, I'm not sure if we need to do it efficiently or if we process the balloons in a smart way. I think as long as we process the balloons in a smart way, that should be good enough. That should be good enough. Let me switch it back to Python 3. I was practicing some Swift. So what we can do is we can use either tools. I think we just import either tools, right? Import either tools, and then from here we say for uh, either tools dot group by, I think group by colors. Then the key, we actually don't need to specify the key here. Oh, what did I do? Okay, we don't need to specify the key here. So if you don't specify the key, then what either tools do group by do is that it will use the value of the element as the key. Otherwise, you can specify a key function to group a sequence of elements into a group. So this group by function, what it does is it groups a sequence of elements that share the same key into a group. So what we will be given is we'll be given the key and we will be given the group in either choose.group by. Then from there we can have a variable called like time, which is equals to 0. Oh my god, I accidentally clicked submit. Okay, so from here you say the time needed Actually, if there's only one balloon, then we don't have have to do anything. So if the length of the group uh, is equals to 1, then we can continue. Otherwise, we say time pass equals the max of whatever is in the group. Wait. No. We need the sum. Oh my god, keep mistyping. So it's not that we need to take the sum minus the max. Yeah. So we take the sum of the group minus the max of the group. So from here, we will get the time plus equals like so. So the sum of the group represents the time needed to move all of the balloons, excluding the one that we will keep, which is the balloon that requires the most time to remove. From there, we can just return time. Oh, okay. This that's because the list is an iterator, so I guess we have to cast it into a list first. List. Max art is an empty sequence. That's because we consume the iterator uh, by casting it into a list. Sorry, friends. So what we need to do instead is group is equals to the list group. So this will consume the iterator. Then from here, group will be counted as a list. And from here, we should be good. Okay, what's wrong? Unsupported operands for. What's the key in a group? Oh, colors is a string. I see. Okay. Colors is a string. In that case, we can zip the colors and the time then. So we can zip the colors and needed time. Then from here, we actually need to specify the key, which is equals to lambda pair. We will return the pair of 0 in this case, because we just want them to group by the colors. Right, from here, the key is the color, and then the group we have a list of colors and their needed time. So from here, yeah, we can consume it. Then we say the sum of this will be the sum of we have the color and time needed. And time in group. So what we want is we want the time in this case. We need the end time, I mean. Likewise here, the max. So we don't need this. It should just be placeholder. This should be good. Okay, so it passed the sample test cases. Hopefully the code is not super complicated here, but maybe I can do wrap instead. I'll explain a little bit more. So what we're saying is, okay, we zip up the colors and the time since they're all the same length. What we have is we have a we have a pair of elements, right? Which is we have the color and the end time, which is maybe I should call it like color of I and needed needed time of I. So this group by will okay. So this zip will color the zip will sort of like combine these two lists together into a tuple like this, with the first element being the color and the second element being the time needed to remove the balloon. So once we zip it, we say, okay, we're going to group a sequence of the elements together by their color. So just to recap, in this case, for example 3, the groups that we have will be the first group of blue, the second group of red, and the third group of blue. So it groups a consecutive sequence of elements that share the same key together. So even if you have, let's say, this, uh, you can't treat the balloons they are not in sequence as the same group because it takes into account the ordering of the elements. So okay, the key, what you get here is actually the color, because that's the key that we use to specify the grouping, and you have the group itself that share the same key. And the group is a consecutive sequence of elements. So we say, okay, what you get here is actually an iterator. You cast it to a list, it consumes the iterator, and then we say, hey, if there's only one balloon there, we're done. Otherwise, we sum up the time needed to remove all of the balloons minus the time needed to remove the balloon that takes the longest time, because greedily that's we want to, because we want to minimize the time taken. In that case, we actually want to remove all the balloons but the balloon that takes the longest. We edit the time and return time. So this is a greedy algorithm. It is, I would say, O(n) in general, because um, we are iterating through the each group. You might think it's like, oh well, like n square because of like the sum and max, and then we are doing like list comprehension here. The reason why it's O(n) is because for each element we are only iterating it 2 times. For example, if you take a look at example 3, we say, okay, we take the first group, we add this to the first group, we add this to the second group. Once we reach the third element, we will say, okay, we process the previous group, right? So we say we sum them up and we take the maximum of them, and then we just do the calculation here and add it to the time. So actually each element is only being processed twice. So in this case, the time complexity is O(n), the space complexity is O(1) in this case. If you don't use Python, it's actually still pretty simple. What you need to do is, no, actually the space complexity is O(n), because we need to, yeah, that's because of the group here that we are keeping track of. So if you don't use like Pythonic syntax, what you would do is you will maintain a temporary list or temporary array. Then you will say, hey, as long as the list is if the list is empty, well, it's quite simple, right? You just add the element. So if the list is not empty, you check for the current element, is it the same as the last element in the list, right? If it's the same, you can just add it to the list. Otherwise, if it's not the same and the list is not empty, you have to process the previous list, do the calculation here, then you empty the list and add the new element that is different to the list. So you just maintain a temporary list as you traverse through the input. So I'm just gonna give this a quick submit. So okay, great. It passed the test cases and I got submitted. So yeah, this is my code. The time complexity and space complexity is O(n) each. Let's take a look at the solution. Yep, you can use 2 pointers as well. Yep, group them together. Yep. So it's kind of it's greedy. Oh, because it's two pointers. Yeah, technically you don't need the temporary list. You can just maintain the can you just use pointers instead. Oh, actually, that's pretty smart. Yeah, that is pretty smart. Yeah, okay. So what approach two is saying is that, okay, as we iterate through the input, right, we we um we calculate the sum for the current group, but we also keep track of the maximum element that we have seen. So once our pointer has reached a different group, okay, we check the previous group. And we say, hey, if the previous groups we can say like the previous group's maximum time and the previous group's total time, if they're the same, that means there's only one element, we can continue. Otherwise, we can take the total sum, okay? Yeah, we can take the total sum minus the maximum sum and add it to the time. But I think maybe they are saying something a little bit different. So what they want to do is instead, once we've processed the new group, okay, we just add the time needed to process the largest group, the largest balloon, I think. So okay, so what I'm trying to say is you process the whole input once. Okay, you keep track of the total sum of the elements, so 6 plus 7 plus 1 plus 2, etc. But as you process the next group, you keep track of the maximum in each group as well. So in this case, you will say, okay, 7, I will actually need to keep 7, and then keep 3 here, and then keep 6 here, I think. Okay, maybe that's not what the editorial is saying, but I think my solution will also work. So you keep track of the maximum element in each group. You take the sum of every element and you just do a simple calculation at the end. So you just add 7, 3, and 6 together and all of the elements to the input. You do the subtraction and you get the answer. Okay, cool, cool, cool. Maybe that's like an upsolve. Yeah. Anyway, that's all for today. Thanks for watching and have a great one.